Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Upgrading or replacing storage drives is a frequent task in IT support and appears prominently on the A+ certification exam. Whether working with traditional hard disk drives or solid-state drives, technicians must understand installation procedures, interface types, and data migration methods. These tasks are commonly performed during system repairs or performance upgrades. Proper execution ensures reliable storage performance and preserves user data during transitions. Hard disk drives and solid-state drives differ significantly in design and function. Traditional hard disk drives use spinning magnetic platters and mechanical read-write heads. In contrast, solid-state drives store data using flash memory, eliminating moving parts and offering faster access speeds. SSDs are more energy efficient and less prone to physical damage. However, they may cost more per gigabyte than HDDs. On the exam, candidates may be asked to compare these technologies based on speed, durability, and cost. Many computers still use the SATA interface for both hard disk and solid-state storage. SATA devices connect to the motherboard using two distinct cables, one for data and one for power. Technicians must be able to identify these connectors and properly align cables to ensure functionality. The A+ exam often tests cable identification, port recognition, and proper cabling for SATA-based drives, especially in desktop environments. Newer systems may use M.2 solid-state drives that connect directly to the motherboard without external cabling. These M.2 drives often use the NVMe protocol, which communicates over PCI Express lanes to deliver high performance. Understanding the difference between SATA and NVMe M.2 drives is essential, as they may use the same form factor but require different slot types. Installation includes inserting the drive at an angle and securing it with a mounting screw. Technicians must use the correct tools and follow safety procedures when upgrading drives. Common tools include precision screwdrivers, plastic pry tools, and anti-static wrist straps. Drive enclosures or brackets may be needed to fit smaller drives into standard bays. All power must be disconnected before beginning any work, and technicians should ground themselves to prevent static discharge that could damage components. Removing a drive from a laptop or desktop involves careful disassembly. In desktops, this may mean opening the case and removing a drive cage or release bracket. In laptops, screws and retention clips often secure internal drives. Disconnecting SATA cables or gently sliding out M.2 drives must be done without damaging connectors. Tracking screw locations and following a safe removal sequence ensures a smooth upgrade process. Installing a new drive requires aligning it with the correct interface and securing it in place. SATA drives must have both data and power cables properly connected, and brackets may need to be adjusted. M.2 drives are inserted into their slot at a slight angle and locked down with a small screw. Correct seating and secure installation help prevent drive detection errors and ensure long-term stability. Once installed, the system BIOS or UEFI should recognize the new drive. It should appear in the storage configuration menu or boot order list. If a drive is not visible, the issue may involve improper seating, unsupported formats, or drive failure. Some BIOS setups may require changes to the boot sequence, especially if the new drive will become the primary system disk. After physical installation, the drive must be prepared for use. This includes partitioning and formatting, which can be completed using tools like Windows Disk Management or command line utilities such as DiskPart. Initialization ensures the operating system can access the drive and assign it a file system. The A+ exam may include questions on file systems like NTFS, FAT32, or exFAT, depending on the context of the scenario. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Cloning and data migration are essential concepts when replacing a drive without reinstalling the operating system or applications. Cloning creates an exact duplicate of the source drive, including partitions, operating system files, and configurations. This process allows the user to replace a failing or limited capacity drive with a new one while preserving functionality. Drive cloning is frequently tested on the A+ exam in scenarios related to storage upgrades and disaster recovery. Popular drive cloning tools include CloneZilla, Macrium Reflect, and utilities provided by SSD manufacturers. These tools may operate from a bootable USB or be installed within the operating system. Cloning procedures generally include selecting the source and target drives, verifying compatibility, and monitoring the progress. A successful clone results in a new drive that is fully bootable and contains all files and configurations from the original system. Imaging and cloning are related but distinct processes. Imaging creates a compressed backup file of the drive, which must be restored before use. Cloning, on the other hand, produces an exact, immediately usable replica of the drive. Imaging is more suited for archiving or deploying to multiple systems, while cloning is typically used for one-to-one replacements. Understanding these differences helps technicians select the right method based on their goals. When migrating to a new drive, it is crucial to ensure that the system can boot correctly. The new drive must contain the necessary boot partition and bootloader. The BIOS or UEFI settings may need to be adjusted to prioritize the new drive. Missing boot files or improperly cloned partitions can lead to startup failures. Awareness of these risks allows technicians to resolve post-cloning issues quickly and efficiently. Encrypted drives present additional challenges during migration. Some cloning tools cannot copy encrypted sectors without first decrypting the source. This means the drive must be unencrypted or backed up through a supported tool before cloning. Tools that support encryption-aware migration are available, but they may require additional setup. CompTIA may present scenarios where encrypted drives must be handled with specific care. Compatibility is another critical consideration during drive upgrades. Not all systems support all drive capacities or interface types. A BIOS might limit recognized drive size, or a motherboard may lack NVMe support despite having an M2 slot. Before performing an upgrade, technicians must verify system specifications, supported interfaces, and power constraints. The A+ exam often includes compatibility questions related to hardware upgrades. Understanding drive form factors helps avoid installation issues. 2.5-inch drives are common in laptops, while 3.5-inch drives are standard in desktops. M.2 drives are thin and mount directly onto the motherboard. Some systems may require adapters or mounting kits to install drives of a different size or connection type. Form factor questions on the exam may require identification of slot types or compatibility with specific systems. Storage optimization is an important step after installing a new solid-state drive. This includes enabling the trim command to maintain SSD performance and ensuring correct drive alignment to avoid bottlenecks. Firmware updates can resolve detection or stability issues. In enterprise or managed environments, monitoring tools may be used to verify drive health and lifespan. Optimization ensures the drive operates efficiently for the long term. After replacing a drive, several issues may arise if steps were skipped or performed incorrectly. These include missing operating systems, unrecognized partitions, or failure to boot. In such cases, startup repair tools or recovery media may be required to restore functionality. Careful preparation, including backups and proper partition management, prevents many of these problems. Technicians must understand both troubleshooting procedures and preventative actions. In summary, drive upgrades and migrations involve multiple steps including physical installation, BIOS configuration, formatting, and cloning. Both HDDs and SSDs appear in the A+ objectives, and candidates must demonstrate proficiency with each. The ability to safely and efficiently manage storage upgrades is a core skill in IT support roles. Whether installing a faster drive or salvaging a failing one, this knowledge is essential for certification and field readiness. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.